my name is Shrikant, and today I'm going to give you some tips and I'm going to talk about some frequently asked questions on writing Olympiads. Okay, so a quick word about me. I basically have been an Olympiad coach for 10 years and over 10 years actually. I generally teach mathematical Olympiads. I mainly teach geometry and Combi. I also teach algebra and number theory, but my favorite is geometry. Uh, I have lectured this year at INMO Bangalore, Chennai, Bhopal. Okay, three training camps, and I met a lot of students who had lots of questions about the exam, this exam, and also RMO exams, and about how to write the exam, and so I thought I'll put in a few questions, answer a few questions about whatever I know about it, and also I'll give you a few last minute tips. Okay, so let's get started. So first of all, before we start, there's a slight difference between RMO and INMO correction, and I think you guys should know the difference between it. The main thing is that RMO generally happens, the corrections happen on like state level centers, and INMO's correction happens on a central level. So in RMO correction, the correction is usually done by maybe smart PhD students with no exposure to Olympiad, culture, which means that you should not. If you write some things that are known only within Olympiad culture, if you try to write that in the exam, it's not a good idea. I mean, they wouldn't understand it, and that might reduce the level of your marks that you might get. Now, in general, it's not always a good idea to write it, I think, because you want to be as clear as possible, and the main thing is you should try to avoid jargon meaning don't use words that are common within the Olympiad community but is unknown in people who have just gone through usual schooling. Like for example, phantom points is a great example. It's very popular in Olympiad geometry, but outside of Olympiad geometry, I don't know if people even know phantom. It's not there in NCERT. You can always avoid saying that word, and you can just write what you mean, and you can prove whatever you want to prove. Be clear, precise, concise, so that the person who's reading it just gets what you're writing. Okay, so basic suggestion is avoid jargon and write clear logical arguments, because people may not know what it is, and they might not be able to appreciate what the words that you're throwing at them. On the other hand, INMO correction is done centrally. And generally they are experienced lecturers or experienced people in Olympiads who are correcting it, often Olympiad veterans, people who have represented India before, or have been in a team before, and so on. And it's again a good idea not to irritate them by new found jargon. I'll explain it in the next slide as well. Some of these jargons are very funny. Fact 5, by fact 5 it follows. Don't write sentences like that and annoy the lecturer. You don't want to put the person who's correcting into a foul mood by saying all this. So either way, this is just as a joke slide. Basically, a good rule of writing is try to write as clearly as possible by avoiding jargon. If you can say something without throwing jargon, why not, right? Okay, so jargon means complicated words that are within the community that others may not understand. Okay, all right. So this comment, by the way, about whether smart PhD students are correcting depends on the state. Certain states have maybe access rather to people who Olympiad exposed people who can correct, but certain states may not have, and all states in India are not equally exposed to Olympiad culture. So this comment will change state by state. I'm guessing Pune, Maharashtra might have RMO correctors who might be exposed to Olympiad as well, but maybe something like the central region or some other regions, eastern regions, maybe they don't have. All of them may not have. Okay, all right. So let's move on to the next slide, and this is very important about proofwriting. I keep getting asked this question about proofwriting. First thing you should know that I have never corrected an INMO paper, but or even an RMO paper, but certainly I have corrected my students answer scripts when I'm giving them my own tests. But I also have met people who have corrected, other resource people had come for the training camps, and I would like to sort of just summarize some general commonsensical tips on writing, which might help you. Okay, and these are just basic stuff, but I just want to get over with, and so that all your doubts, as much as possible, I'll try to clarify. Again, this is not some official statement by the Math Olympiad cell or something. You should ask them for the actual guidelines that they follow, but I would think these are the ones I'm sure is reasonable. Okay, all right. So the first basic thing of writing, which students misunderstand, is that the correct way to write an exam is that you should write to be understood. So there's a difference between writing a diary and writing in an exam. Okay, when you write in a diary, you might be just writing something that, I mean, if you're just writing that, you're using the diary to express yourself. Just whatever inner desires you have, inner hate, I mean, emotions you have, hatred, happiness, anger, whatever you want to get that out. Then you write a diary. I mean, that is writing to express yourself. That's very different from writing to be understood. Okay, so one of the main things is when you're writing a proof, your aim in mind continually should be the person who's correcting it, will this person understand it? And you don't know who this person who's correcting is. You just know it's a smart person who can understand arguments, but you don't know whether they know every small bit of things that you are assuming, right? So try to make sure you state things as clearly as possible without much complicated words, without try to keep it clear and concise, and write so that you believe a person who's not exposed to Olympiad culture can understand. Especially for INMO, that is very good advice. Now, state the theorems you are using completely and accurately. Okay, don't state half of it, and even when you apply it, if you don't use it, it's a clear indication that you don't understand how to apply the theorem. So try to state it completely and accurately as much as possible, uh, especially when you're stating it without proof. Secondly, avoid only using jargon. And this is a very specific command. And when I said avoid using jargon, what I don't mean don't say shooting lemma or don't say phantom points or fact 5. I mean, if you say it, at least say that is and explain what the statement is. So this has a double advantage. Like if there is someone who's correcting who already knows what shooting lemma is, or phantom points are, or whatever a fact 5 is, then that person knows, it knows already, doesn't have to read what you're writing. But the person who does not know will at least read that is and understand, okay, you're explaining what that is. And it might help, it might educate, expose the person who's correcting a little bit to Olympiad culture as well. So it's always good idea to, may not be a bad idea rather, that if you are using jargon, just say that is and quickly explain what that is, okay? Especially when you're using it for the first time in the paper. The next thing is the same goes with the acronyms. Okay, so acronyms, I have seen these acronyms sometimes they surprise me. Things like by PMI. What is PMI? I have no idea. And then I'm like, oh, I think they mean principle of mathematical induction. I have to reverse case, and I always keep wondering what, maybe I missed something, maybe there is some argument that's missing when I see it. FTSOC, this I've seen quite regularly, for the sake of contradiction. I mean, you can just say in the start of the proof that we proceed by contradiction. Let's assume the following is, let's assume the given statement is not true, and you can sort of proceed. I mean, you don't have to say FTSOC. That amount of time you're buying yourself by not writing a complete phrase, I don't think it's valuable. I mean, it will certainly be better, I think, that as long as you write in good English full phrases, don't use shortcut notations, don't use for all there exists, right? Write in full English as possible. When you are scribbling or you're writing on a board and talking to some partner who knows, their level of exposure to symbols and so on, it's fine, I get it. But when you're writing an exam, you don't know who's going to correct. It's always safe to write full English, and again, write to be understood. That is the major principle, okay? All right, now this is another tip. So it might happen that you might do some calculation, and either you observed a pattern, or you did some long calculation using some finite difference. So maybe there is some sequence and you want to compute a formula for the nth term of the sequence. You can do this by generating functions, maybe if there is a recursion, or you could do it by some finite difference theory, right? So there are lots of these methods which will sort of very heavy duty methods that will sort of give you the answer. Now, one thing is that you could try to show that derivation, but then you have to justify all the steps you're using and everything. The other thing is that sometimes you can do this in the rough work. You can sort of compute things using some heavy duty methods, but maybe the proof becomes very clear if you try to prove it by induction. Imagine these recursion problems, right? If somebody gave you the complicated formula that you were not getting, if you just plug, by proving by recursion is very easy. You just plug in, check the base case, and then plug into the recursion formula and check they satisfy, right? That's much easier. So the proof might be easier to understand for the corrector if you are, writing using induction, even if you're not telling your motivations. On the flip side, there is a small catch. That is, if your formula is wrong, right? If your formula is wrong or you made some mistake, then it helps, I think, for the corrector to know where the formula came from to give you part marks or something like that. So it may not be a bad idea to sketch where you sort of got it from with a few keywords or something, to tell the corrector that, look, hey, I know this method, but I'm not going to use it. I'm going to use induction to prove it. That sort of at least might fetch you part marks if you made mistakes. Okay, but certainly remember, in some sense, once you have a correct proof, more important than motivation is basically clarity of the proof. If the proof is very clearly written, the corrector would love it, because at the end of the day, please make the corrector's job easy, because they are going to correct lots of papers, hundreds of papers, and it's basically the faster they can get through a paper is better. So keep that in mind, be kind, and try to write and be proof in such a way that's easy for the corrector to correct, just so that the corrector can just say, ha, yes, this he or she has hit the right boxes, and we can go ahead. Okay, all right, so that's what I mean by induction proofs could be short. Also, avoid writing clearly and obviously. You can say clearly that triangle is isosceles. I mean, instead of clearly, you could say why you think it's clear, right? You just will take hardly a phrase. So you can say the triangle is isosceles since we already shown by 3 and 4 that base angles are equal. Since by 3 and 4, I mean, okay, this goes into, by the way, the next step. Is number your equations and observations as much as possible and use them to refer. Like, you want to prove some angle equal to some angle, blah, blah, blah. Then you can say from 3 and 4, we know the angles are equal, and therefore the triangle is isosceles. So you don't have to say clearly the triangle is isosceles. Instead of that, you could just say this, and it helps the person who's correcting, and it won't take much if you're labeled by 3 and 4. You can even, if you're in a hurry, you can say by 3 and 4 we see that the triangle is isosceles. That's okay, that's still okay. I mean, you're at least referring to what you have claimed, right? And we can go back there and check what you're doing. If I'm not corrected before, but I'm assuming if anybody's going to correct, they're going to look back and check. So I would say try to number your equations and avoid writing clearly, obviously. Okay, all right. It's always a good idea to, once you solve the problem in rough, if you want to start writing the proof, instead of immediately starting to write the proof, it might be a good idea to pause and collect yourself for a few seconds, maybe less than a minute, and consider how you are going to structure the proof. And that will save you a lot of time in writing. This small 1 minute that you will spend, I think, can save you sometimes a lot of time, because if you just try to see how you'll order the things, you'll realize that, oh, maybe I have to prove this lemma before I prove this, because as you start writing, you realize, oh, I need this lemma, and so on. That ordering becomes a problem. If you're typing on a sheet of paper, is fine, you can keep writing, but when you're writing, if you realize you need something, and the order is all screwed up, it might be a problem. So it's generally better to package the things you need into a lemma, bunch of lemmas, and then quote the lemmas and just write the proof. It generally will help the corrector as well. And also, you might get part marks for the flow if in case you make mistakes. So I would say these are all general writing tips, nothing to do with Olympiads, but please pay attention to this. Okay, this is my suggestion. Again, this is not from HPCSE or Math Olympiad cell. This is just one Olympiad teacher just trying to help the students out. Okay, all right. So since I generally teach geo, and I've seen lots of geo papers, students writing geo in their books, here are some tips for geo. Okay, for geo, one of the things that students don't do is draw a clearly labeled large accurate diagram. Now, you don't have to. Okay, there are many students who have gotten used to not drawing and doing good geo. No problem. But this is for people who are actually struggling with geo. If there are people who say, oh man, I struggle with geo, I just don't get it, and so on, I would say a good first step is to draw clearly labeled diagrams. Okay, some people might be really skilled at geo that even if they draw bad diagrams in their head, the diagram is correct, so they can see their lines, the correct lines in their head. Some people are skilled at it, but for others, if you're just starting out and you want to enjoy geo, this is a general tip while studying. Try to draw accurate diagrams. And also for the corrector, when you're writing an exam, I feel it gives a psychological sort of you sort of make the corrector feel happy. I feel that when you draw a proper diagram, okay, that you feel we understand it. Okay, if there's a complicated problem, maybe problem 5 or problem 6, we sort of see it, and then you can say, oh, okay, this person has understood the question. Okay, sometimes students don't even understand the question. So I don't know whether you'll get part marks. In fact, there are exams where I think some USM or some exams I've seen where they've clearly said if you don't draw an accurate diagram, we'll subtract 1 point. Because this has gone to an extent where people don't draw diagrams or don't draw proper diagrams that they have said this. So I don't think they do it in INMO, but they should, I would say. Okay, please draw it. Use the compass and the straight edge given to you, because geometry is as much mathematics as it's a science, you have to make observations, you have to draw clearly accurate diagrams, and then you might say, oh, these ones are parallel, and these 4 points are concyclic. So you have to make observations on your drawing at the end of the day, okay? So please do that. And usually in rough work, again, you might have to do multiple drawings. So please be aware of that. I'm saying this statement because many students, I believe, give up when they draw a diagram and they first try it for a couple of times and they don't sort of get the correct drawing. They just give up. That's not how it is. You have to draw multiple drawings sometimes. Sometimes drawing only is hard. Some conditions are very hard to enforce on the picture, on your drawing, the kind of conditions they give in the problem. So you have to draw it multiple times before you get the correct drawing. And that's normal in geo. It's very common as you go up the difficulty ladder. It gets drawing is basically a good skill, okay, and you have to develop that. Okay, so the third thing is be very careful of configuration based issues. Now, I don't know how much people penalize configuration based issues in Indian math Olympiads. I've not talked about it with anyone. Maybe they don't do it so much is what I guess. I'm guessing, but it's better to be safe because some problems, it might be crucial, right? And you might lose 1 or 2 marks and might not cross cutoff. I'm worried about that. So if they penalize you like a small point, but that might push you back. So I would say try to make sure you are aware of configuration issues. And this again goes back to drawing multiple drawings. Try to draw an acute angle triangle, try to draw an obtuse angle triangle. Try to draw as much as possible and to make sure you know that there are no configuration issues. Another thing is to, of course, use configuration independent techniques. That will obviously save you. Just use directed angles for doing some angle chase, or you can do configuration independent techniques like complex methods or coordinate methods or vector methods or something like that. Okay, so the next thing related to this configuration independent methods, especially complex coordinate or vectors, is students try to bash their way through all this. The so-called bash word is introduced, I guess, to mean meaninglessly manipulating stuff. Okay, I think that's what they mean when they say bash. Now, not all complex or coordinate or vector methods need to be seen with that ugly lens. Sometimes the proofs are beautiful even if it's algebra. I don't think all bash is bad per se, but I think bad bashes exist in the sense that where you are just blindly manipulating without any hope, or I mean, it's after all an exam, right? You want to crack it, so I get it. So but the point here is that you don't have to go with that mindset. Okay, that's all I'm saying. My suggestion is not that don't bash or bash, it's fine, do whatever you like. But don't go with the mindset of I'll take a problem and I'll bash it through only. I mean, okay, you can try that, but you can also try to draw and you can make sub-observations and you can take a sub-part of the question and try to use complex methods or coordinate methods. And I think I've seen this been done multiple times, although it's not as common in proofs online. I think we should normalize that. Trying to basically, as a geometer, use every tool at your disposal, right? Why should you want to do it only by one method over the other? Use whatever looks nice, whatever makes you feel happy. Use a mix of all the methods. Part of the proofs can be trigonometry, part of it can be pure geometry, synthetic, part of it can be projective, whatever. I mean, do a mix of techniques, okay? Use anything at your disposal, basically. Those are my tips. Okay, the last one is a bonus tip. Many people don't do it, but in the exams also you don't have to do it. But for me, if you to study geometry, it's very useful to use colors, all things of the same length with the same color. I always use color chalks to teach as well. I think it helps me visualize things. Okay, so it helps also to clarify to the viewer, which lengths are equal. It's instant. Color coding is instant. So, I mean, of course, colors, you need to know how to use it. But if you've not developed that habit, maybe if you start doing it maybe by next year, if you are good at it, then you can use it in the exam as well. Okay, I mean, if they allow it. I hope they allow color pencils or color pens. Okay, so the next thing is Combi tips. There are not many, but there's just some pitfalls I want to sort of tell you. So first thing is Combi mistakes are sort of subtle. I mean, even if I give you a tip, I don't know how helpful it is if you're not careful, if you don't carefully think it through. So sometimes the arguments what students write are very wordy, which is fine. Some problems are like that, but as much as possible, if you could try to translate that into notations, sometimes things will become clearer. Okay, it will become clearer to you, not just the reader, even the writer itself, that the argument is not complete. So there are many examples of this. Maybe I don't have right now examples to show. Maybe in another video I'll go through these kind of examples where proofs could be written better. So basically, avoid long wordy arguments as much as possible. Keep it clear, concise. Even if it's full of words, it's at least keep it precise and to the point. Okay, as much as possible. That's what I would say. Um, Next thing is about this we saw in multiple places. In Bhopal also we saw, and in other places also, where questions about proving minimum maximum if you have some kind of an optimization problem. The Combi resource person at Bhopal was noting that many students don't realize it has two parts. One is that you have to say that something, well, if you want to prove something is the minimum, then you have to argue anything below that cannot be achieved, and you have to show that that bound that you talked about can be achieved. There are two parts. One, construction to achieve the bound. The other, to show below is not possible. Now, to show below thing is not possible, use some invariants or some kind of arguments to, some impossibility arguments. You show some kind of obstruction you construct. On the other hand, to show achievability is always a construction. So often you can use induction in that situation and stuff like that. Okay, so but it should be some construction basically. Okay, but there are two parts. I mean, even recognizing that there are two parts is important, and many students don't recognize that. They just do one part of it and they think they are done with the proof. Okay, so just be aware of that. That's it. So finally, yeah, okay. So here is some extra tip, especially for Combi. But it's also true in general, by the way. This tip is general, but especially for Combi. So it will be a good idea to summarize everything we have discussed now. So here's an example. So we will construct, here's an example of how to write a proof. So we will construct a monovariant that is a bounded positive number that decreases every round. This is sufficient to show that there will be finitely many rounds. Now, if you write this sentence at the start, if you want to use monovariance in your argument, let's say, and you write this at the start, notice what happened here. You are sketching what you're going to use. You also used a jargon, monovariant. That's not common, right? But you said that is and explained it to the reader, right? So the reader now knows, okay, the word monovariant means some bounded positive number that is decreasing every round. All right. And this is generally used to show that, there are only finitely many rounds because, there's a finite number and it is bounded below by 0 or something. And now at every step is decreasing. And so there can only be finitely many steps, after which, if it's more than, if there are infinite many steps, eventually it will cross 0, right? And so essentially, this kind of an argument is, you can use it, it's fine, but is an example where you write down the jargon and you explain what it is, and you also, more importantly, sketch the outline before you, you sketch the attack on the problem before you start going into the details. This is generally good writing advice, I would say. A couple of lines written will help orient the reader what you're going to do. Okay. All right. Some frequently asked questions. This was asked across camps, in all camps basically. First is, should I attach rough sheets? Now, yes, you should. That's the answer. And there are multiple resource people who had corrected last year's INMO and RMO have told us that, last year, rough sheets made a difference. I think the cutoff was 52 or something, 53 or something. 52 is like 3 problems. And there were students who got 1 mark, in one problem for making an observation, sometimes in the rough sheet. Okay, sometimes in the rough sheet. So when they attach rough sheets, you can see what progress people have made. If you don't attach rough sheets, that's a problem. Even if you had made observations in your rough sheet, you would not get marks for it. So I'd say in Olympiad, since you never know whether you're making a progress, attaching rough sheets is very useful. Okay, so just do your rough work and attach it. You might get some marks. I'm not guaranteeing it, but sometimes. Okay, and it sometimes can make a difference, like last year, where people cross the cutoff due to 1 marks given in rough sheet. All right, is it useful to write partial progress? I've heard that you do not get part marks. This is something I have heard, not very frequently though, but some students have said that to me. Their point is right. Why should I write? If I solve it, I solve it. It's not a good idea in Olympiads, especially because it's a time-bound exam and you might have made some observations, and actually those observations might be in the right direction. The problem is, in problem solving, you only know what is the right direction once you have reached the end. You can look back and say, aha, all these things were needed. But when you're solving the problem, in the midst of it, if you have not solved it, you have not completed, you never know what was the correct direction. Not always, sometimes you know. But very often, you are worried that what you're doing is a dead end. Now, in this case, it helps to report on partial progress, right? Because if you report on partial progress, the corrector can take a call on whether you have made progress or not. Okay, and the thing is that rough works also help here. I mean, you can the correctors might sometimes look at rough work and give you part marks. But so it's always a good idea to report partial progress. Don't write scores of things in the rough and don't write anything in the final paper. Okay. All right. Just report your observations and what your strategy is to attack the problem. All right. A few sentences should be good enough. All right. Coordinate geometry proofs are given less marks. Is that true? This is one of the most frequently asked questions. Apparently, there is some rumor going on that coordinate geometry correct proofs are not given marks. I don't think that's true. Any proof that is correct, I think, will be given marks. I mean, as long as you don't trivialize the problem by quoting a theorem that is essentially solving the problem or something, I think as long as you've really worked it out and all the steps are correct and you've correctly justified all the steps, I think you should be, I mean, you should get marks, okay? So don't worry about that. You will get marks even if you use coordinate geometry. And in RMO, more likely, if it is being corrected by people who are not exposed to standard Olympiad techniques, but no coordinate geometry, in fact, more likely you'll get marks. In INMO as well, I would say, as long as you're quoting all the things you're using and you're using fairly elementary stuff, it should be fine. Now, if you use advanced stuff also, I mean, it should be fine, but you should quote it correctly, okay, and use it so that the examiner knows what you're using, I think. All right, this is my opinion of it, but I would say I don't think there is an issue with coordinate geometry proofs. The only problem will be that you may not get any part marks if you leave the calculation halfway through, okay. That might be the reason to avoid using coordinate geometry proofs, I mean, especially bashing. If you make observations though in coordinate geometry in between, still you'll be given marks though, okay. I mean, if you pause and make observations and if you're close to, I think you should be given marks. It depends on the person who's correcting though. Okay, second thing, is it true that use of calculus is not allowed? Well, the answer is a little complicated, I think, here. Again, I am not a HPCSE spokesperson or something, Olympiad cell person, but I think from just common sense, is it true that the use of calculus is not allowed? Well, it's sort of yes and no. I mean, you can use it if you know what you're using. See, the problem is that, I think lots of students think they know calculus and they may not know the full statement of the theorem and they're careless in using it. They think they used it correctly and they didn't get marks, okay? So a great example of this is if I ask you to compute the maximum of a function, there are lots of students who will just differentiate and set it to 0 or even do the second derivative test and then say, hey, I did the whole thing, I solved it. Not realizing the exact statement of the theorem is that it will detect local maximas, okay? So when you differentiate and set to 0 and you even do the second derivative test, what you get is essentially, let's say, a local maximum or a local minimum, okay? It doesn't guarantee that it's a global maximum or minimum. In fact, if the function is defined on an interval, it's always proved you should test it on boundary points, because take the function f of x equal to x defined on the interval 0 to 1, right? If you differentiate, it's 1 and 1 equal to 0 has no solution. So you might say there is no maximum or minimum for f of x equal to x on the interval 0, 1, but there is, right? The boundary points. F of 1 is 1 is the maximum actually at the closed interval 0, 1. So essentially, the problem with calculus and more powerful techniques like group theory, calculus, anything, any advanced technique that you're trying to use is that it's possible that you are not equipped to use it. And you might use it wrongly, and that's more likely to happen according to me. So I would suggest, just for that reason, because you wouldn't know that you don't know, right? You use don't use calculus, okay? You use elementary techniques, right? Use some AMGM inequality and so on. If you want to use Jensen's, please do quote it correctly. You can use it, but just make sure that either when you're using calculus, make sure you know the theorem precisely. Or be willing to lose marks, okay? Because or else it's a gamble, and that's just really holds for anything. It's not just calculus. Calculus was a placeholder here, which is most commonly asked, but it can be any complicated technique. Okay, group theory also. Maybe you don't completely understand the definition of a group, or you don't understand the statement you're using. Let's say orbit stabilizer theorem. Whatever theorem you're using, as long as you know it precisely and you used it correctly, I think they'll give you marks. Why not? I mean, as long as the proof is correct, right? So do I have to prove 9-point circle theorem or any other theorem? Now, this is a question people ask, and I think students don't know which parts to prove, which parts not to prove. So a good rule of thumb here is difficult, actually. So for example, the so-called shooting lemma, right? When you have two circles which are eternally tangent and you draw a chord that is tangent to the smaller circle inside, then the point of tangency, common tangency, the point of the chord tangency, when you extend meets the midpoint of the arc or something, I mean, whatever that is. That is called shooting lemma. Now that maybe you have to prove. I think that's not so common enough. Whereas 9-point circle theorem is fairly popular in math literature and especially in Olympiad literature. So I think it's okay. You can just quote the statement of the theorem and you can use it. Okay. Now, I would say that it's quite difficult to decide. It changes, I guess, decade to decade about what kind of things you have to prove and who your audience is. It's a safe bet to prove things that are obscure. But again, that depends on what is obscure, depends on which circle you're moving around in. So I think you'll have to take a call. But if you are questioning whether you have to write a proof of it or not, maybe you should. Again, very standard stuff like 9-point circle theorem and other things, I don't think you have to prove. In syntax and lemma, you can just quote it, I think. I don't think you have to prove. Uniqueness of representation of base, that binary representations are unique for every number. I think you can just quote it. You don't have to prove. I think so. Okay, that's my belief. I guess if you look at HPCSC webpage for Olympiad syllabus, anything that's covered in the syllabus, I would say you can safely use it without writing a proof for it. That's what I would say. Okay. I guess that's the end of my videos. So see you all